it was big enough, it could have been some kind of, maybe some obstructive symptoms. What about protein and potassium? They could have been losing that, right? Okay. All right, so good deal. Okay, this is a... Yes, you can't. It's hard, I'm telling you. And if I screw up and say the wrong thing, it's even harder.
What ingredient that we have from like the healthy, happy cells?
Right.
There's this thing called carcinoma in situ.
Yes.
So carcinoma to me means malignant.
Yes.
So that's a malignancy in situ, meaning it's not yet invaded.
Correct. So what? So our transition is normal, like you said. Nothing's wrong. Everybody's happy. Then it starts proliferating a little bit. So maybe the cells look normal, the nuclei look normal, but they kind of start piling up a little bit. Right. Then dysplasia, low grade. Then with time it moves into high grade dysplasia. Then further beyond that is carcinoma in situ. And then beyond that's invasive.
So carcinoma in situ is just like
it's
dysplastic?
Right. It's super dysplastic before it becomes invasive.
Okay, so it is a malignancy.
Yes.
Has not yet
Right.
invaded anything.
Right.
We're happy we got it now.
Exactly. Exactly. What's that? What'd you say?
I thought malignancy meant that it had invaded.
No, carcinoma in situ is considered an in situ carcinoma. So invasive, if we say invasive carcinoma, that means it's gone beyond the basement membrane. But in situ means it's still within the basement membrane. I know, it's hard to get your head around it. I'm sorry.
So just to follow up on this question, when you're talking about the classic pathway towards malignancy, you're talking about exactly what you just
Right.
described, leading to CIS, which is carcinoma in situ.
Right.
What is exactly chromosomal instability that is also called CIS?
Okay, so chromosomal instability.
That is not the classic pathway, though?
It is. So, okay, so the classic pathway refers to chromosomal instability. So you start with APC. When you get that mutated, that's kind of you're on the launching pad. Then you accumulate these other mutations along the way, in a stepwise fashion. So it can be KRAS, P53, deleted in colon cancer, all these things. And if you keep having them, if your polyp sits there long enough and you don't have it removed, then eventually it can go all the way along this sequence and become invasive carcinoma. So let's just say it again so that everybody's clear on it, okay? Because it's hard to get your head around. So you've got normal, kind of piled up proliferative dysplasia. So with dysplasia, you start low grade, then you get to high grade, carcinoma in situ. Then to go invasive, you have to breach that basement membrane. And it can be just barely invasive. It could be still up in that mucosa, just intramucosal carcinoma, or it can be all the way through, into the bowel wall. Now, having said that, that's, like in our minds, that's how the process works. If I get a specimen, usually I can see a bunch of dysplasia and high-grade dysplasia, but I'm not going to see carcinoma in situ. It's gone beyond that. If it's been removed, a lot of times you're not going to see every little phase. You're going to see stuff that starts to look dysplastic, then boom, it's high-grade. But in theory, if you're kind of thinking about it in your mind, it's this orderly, stepwise thing. The other thing you have to keep in mind, and this is hard to think about, so if somebody has something like FAP, right, which is going to be the classic pathway, you've got every cell in that colon has a mutated APC gene. So they're going to be in different phases at different times theoretically. So it's just which ones become, and you're not going to, that's why they do the colectomies. You're not going to be able to biopsy all of them and know which ones are at which phase of dysplasia, right? So it's kind of hard to think about, but you just kind of got to accept the concept. And, sorry. Yes.
So just to clarify our initialisms,
Yes.
CIS causes CIS.
Very good.
Okay.
So now, What happens if you have microsatellite instability? How do you get cancer that way? Same thing, right? You wind up with dysplasia kind of in the same way, because you can't go from normal to cancer. You can't go from low grade to cancer. You know, you have to go through the think of it like this. Think of it as you're kind of going along that process, you're accumulating biologic aggressiveness. So it can't go from normal to all of a sudden I'm going to invade to your serosa. It has to go along that. But yeah, but all of them kind of, and so yeah, it's just, but you, I mean, it's hard to explain, but you may not see all phases of it when you get a resection specimen. But it's kind of like, you know in your head that it had to happen. Does that make sense? So you think it's good?
So
No? I'm sorry.
if they all go through the same pathway, why aren't they all called classic pathway? Why are they divided into this? and
So when I
that?
say pathway, the pathway is the morphologic pathway. The morphologic changes. They all have the same morphologic steps. The chromosomal genetic changes that they take to get there are different. Does that make sense? No? I'm sorry.
I think about it.
Yeah, think about it. Think about it. You guys can find me later. I'll be around. I'll be around. So don't, yeah, it's hard stuff to think about, I think. Okay. So what is this thing? What do you guys think this thing is? Here we got something that's kind of round and looks pretty small caliber. And here it's got this mucosa on the inside. And then here's a longer piece, but same thing. What is this thing? Let's go to a higher power and see if we can figure it out. So it's something that's got glands and it's got a lot of lymphoid tissue. And it looks like it's pretty narrow, pretty small caliber. Appendix, very good. Okay. So this looks pretty normal for the appendix. You have a lot of lymphoid inflammation, maybe some acute inflammation if you had it out. And this one has something else going on. What's in there? What are these things? No, this one's kind of a trick, I think, because we haven't really, it's a little bit different than, let me try to find one that looks good like I showed you. No, but you're right that there are a cluster of cells. Yes. I'm trying to find the best picture, but I'm having a hard time finding something that shows exactly kind of like what we looked at today. So carcinoids can be kind of tricky because they're kind of subtle. It's just kind of percolating through there. And it's these little clumps of cells. And let's see if I can find Okay, let's go higher. Okay, so your magnification is better than mine. So here are the carcinoid cells, and they're these little groups of cells, and they kind of look like their neighbor, and they don't look too horribly atypical, and they've got a little bit of cytoplasm, and they're just kind of percolating through the tissue there, and that's kind of classic for carcinoid, the appendix. So, is this going to behave badly?
Probably not.
No, I mean, and it looks kind of scary because it's like, if you back off, you say, wow, but that looks like it's infiltrating. It looks like it's going everywhere, but it's contained within the appendix. So as long as it's contained within the appendiceal wall, and I'll have to just tell you, see, you can see it, but it doesn't go beyond the wall. And I will tell you, I'll have to tell you, well, maybe this is it. Let's say this is our surgical margin, and it's negative. So we've got it completely removed, right? And this appendix looks small. So it's going to be less than a couple centimeters. Doesn't have necrosis, doesn't have nuclear pleomorphism. Remember we said most of the ones in the appendix, you just remove them and that's it.
I have a question.
Yeah.
That note
Oh, really? Let's see. Oh, let me look at my pictures. I've been just kind of freely, honestly.